Hello everyone, welcome to this video. So from today's video we are going to discuss with one important subject of 4th sem, which is the first subject, that is electromagnetic theory. Okay, so I have re-uploaded these videos because the module 1 I had already uploaded, but those videos were not of good quality and was a bit poor in the explanation and all. So it was not done by me, it was done by my friend. So he suggested me to redo it. So already 4 videos were uploaded, right? So in those 4 videos, whatever the concepts which he had taught, that only I'm just going to brush it up. Okay, where I'm not going to solve any problems, just I'm just going to show the questions, and already I had solved it, so that I'm going to revise it to you all. Okay, so this is the module 1, module 2, 3, 4, 5, it is already uploaded. You can check out the playlist. Okay, all the module 2, 3, 4, 5, each and every concept explained in a detailed manner. Please go and refer it. Okay, so most of them have demanded that module 1 videos you required, so that's why. So I've re-uploaded the videos. So module 1 is the Coulomb's law. Okay, so let us again brush up what is Coulomb's law based on electromagnetic theory. Okay, that is Coulomb's force of attraction. Okay, we have come with an equation, right? So let us discuss that equation now. First, the statement: force between two charges is directly proportional to the product of charge magnitude and inversely proportional to the square of the separation between them. Okay, according to this statement, we have written one equation here. Okay, that is force between two charges, that is Q1 and Q2 as mentioned in the diagram. This is a 3-dimensional diagram with X, Y, Z axis and an origin. Okay, this is the point charges in free space. Wherever you want in this 3-dimensional axis, you could be keeping the point charge. Okay, and from the origin to the point charge, drop a line, and that line is called as position vectors. We have mentioned it as R1 and R2, and you should be intersecting a line between 2 point charges. After intersection, the vector passing through that line is called as R12 vector. Okay, where this is the first point charge Q1 with respect to X1, Y1, Z1, and this is Q2 with respect to X2, Y2, Z2. Okay, this if you stretch this line, this is the force acting on this 3-dimensional surface between these 2 point charges. Okay, so this was about the basic description about the figure. Okay, now let's get to the equation part. As per the statement, I have written this equation, that is force between two charges Q1 Q2 is directly proportional to the product of charge magnitude. That is, it is directly proportional to the product of charge, that is Q1 into Q2, and inversely proportional, that is divided by square of the separation or the distance between them, that is mentioned given by d square. Okay, so now here if you want to remove this proportionality sign, just make this rewrite this equation as F is equal to K times Q1 Q2 divided by magnitude of R square. Okay, because the magnitude, the distance value is always positive, so that's why in order to reduce the negative constants, we are applying a magnitude. Okay, so where K is called as a proportionality constant, and is given by, generally K is given by 1 divided by 4 by epsilon naught. Okay, where this has a standard value that is given by K is equal to 9 into 10 power 9. Okay, or you can write 1 by 4 pi epsilon naught, where this epsilon naught is the permittivity of the free space. Okay, it is given by permittivity of the free space, and it also has a fixed value, that is 8.854 into 10 to the power minus 12 volts per meter. Okay, where this comes from epsilon is equal to epsilon naught into epsilon r, where epsilon naught is the absolute permittivity of free space and epsilon r is the relative permittivity. Okay, yeah, so now let's get to the equation part further. That is, also in vector form you could be representing the position vectors as R12 is equal to R2 minus R1. Okay, the distance of separation between the 2 point charges when it is adjoint, it is given by R12 is equal to R2 minus R1 in general. Okay, now let's get to the unit vector part, that is small letter R12. Generally unit vector, how it's defined by, if you have studied the vector algebra, just try to recall it. R12 is given by vector R12, capital vector R12 divided by magnitude of its vector. Okay, so now in this equation, whatever we have written, substitute that is F is equal to, in place of K I have told you, write 1 by 4 pi epsilon naught. So 1 by 4 pi epsilon naught, write it first. Q1 Q2, 2 product of charge magnitudes, into now you include a unit vector R12 divided by the square of the distance between them, that is square of the magnitude of r12 square. Okay, so in this way the Coulomb's force of attraction, the equation of force is given in this form. Okay, so we should be mentioning what and all are the terms here, that is q1 q2 is the product of charge magnitudes, it is given in coulombs. Okay, you know that the SI unit of charge is coulomb. Then magnitude of r12 is the distance of separation. Okay, then the small letter this r12 is the unit vector. Okay, so this was about the description. So in brief, they would be asking this for around 6 to 7 marks. Okay, the statement, the complete statement carries 1 or 2 marks, the figure illustrating the statement and the equation based on the statement and some of the important parts. Okay, so if you write this much, you would be getting around 6 to 7 marks. So this was about Coulomb's law. Okay, so please go through it. So now, based on the Coulomb's force of attraction, based on this force equation, we are going to discuss few of the problems now. Okay, I have already solved it and kept. Okay, so I'm just going to brush you up. Okay, how to solve those kind of problems. Very easy one. Just listen to what I tell, and you could be easily solving it. Okay, so now I have 2 to 3 problems. Let us discuss that. So this is the first question. Consider a charge Q1 with the value of 8 into 10 power minus 4 coulomb at the points given as 1, 2, 3 meters. Okay, so these are the coordinates in the 3-dimensional surface, that is x, y, z. Since they are given 2 points, so this is x1, y1, z1 and this is x2, y2, z2. This is for charge q1 meters, and q2 they mention it as minus 10 to the power minus 4 coulombs at 2, 0, 5 meters in vacuum. Okay, this could be written as in vacuum, or you could be considering it as free space. Okay, if the word vacuum or free space is mentioned, you should be keeping in mind that the value of epsilon is equal to epsilon naught. Okay, this thing you should be keeping in mind. Okay, whenever they have mentioned vacuum or in free space, in most of the problems they would be mentioning it. In some problems, in order to trick you up, they would be mentioning they won't be mentioning any vacuum. Instead of, if they won't mention, you should be directly substituting epsilon naught, that is 1 by 4 pi epsilon naught, this one. Okay, if they don't mention vacuum, this is the general form. So this is the question. Find the force exerted on Q2 due to Q1. Okay, force exerted on the charge Q2 due to the charge Q1, they have mentioned it. Okay, for that you should be finding the force first. Okay, using the equation which I have already seen. Let us see how to approach this problem. First, write the force equation as mentioned, as I've told you, Coulomb's force of attraction, that is product of charge magnitude into the unit vector divided by 4 pi epsilon into the magnitude square. Okay, here in this case epsilon is equal to epsilon naught. I've told you already, because they have mentioned it as vacuum. Okay, now find the unit magnitude r, which is in this equation, it is equivalent to r12. Okay, r12, that is equal to r2 minus r1. Now we should be individually finding, in order to find the value of r12, find individually what is r1 as well as r2. Okay, that is r1 is equal to 1 minus 0x, that is consider the x values, that is x1 and the origin. Okay, x1 is 1 here, we should be having the minus with the origin as mentioned here. x1 minus 0, x2, y1 minus 0, z1 minus 0. Okay, in the same way you should be finding for r2 as well. So 1 minus 0 into a cap x plus 2 minus 0 into a cap y plus 3 minus 0 into a cap z. Okay, now solve it. We would be getting 1 minus 0 is 1, so ax plus 2 minus 0 is 2 into ay vector plus 3 minus 0 is 3 into az vector. Okay, so this is the value of r1, that is ax plus 2ay plus 3az. Now similarly find the value of r2 as well. Okay, that is 2 minus 0, 0 minus 0 and 5 minus 0. So this term goes. So again, if you want, you can write it. So 2 minus 0 is 2ax plus 0ay, 5 minus 0 is 5az. Okay, so this is r2 and r1. Now do the subtraction, r2 minus r1, that is all the ax, ay and az coefficients, you should be subtracting it out. Okay, so 2 minus 1, that is 1, that is ax itself. Then 0 minus 2, that is minus 2ay, then 5 minus 3, that is 2az. Okay, so this is the value of r12. Now we should be finding the magnitude of that vector r12. Okay, you know how to find the magnitude, right? Again, recall the vector algebra concept, that is all the coefficients, right? You should be taking its square root along with the square. That is, here we have coefficient is 1, so 1 square plus minus 2 the whole square plus 2 square the whole root. Okay, so after solving this you would be getting 1 square is 1, minus 2 square is 4, 2 square is 4, 4 plus 4 1, yes, 4 plus 4 8 plus 1 9, square root of 9 is 3. So this is the magnitude of R12 we got. Now unit vector R12, according whatever is there in this equation, we are going to find it out. Unit vector R12 again, R12 divided by magnitude of R12. What is R12? We have got one answer for R12, right? Write it that. Divided by magnitude of R12 is 3. Okay, so divide 3 individually for these 3 terms, and this we will be getting as the unit vector. Now you will be finding the force F12. If they mention force exerted on Q2 due to Q1, it's always the force is given as F12. Okay, if they give in the question Q1 due to Q2, then it is always F21. Okay, if this becomes F21, this vector also becomes R21. Everything changes. So here, if this is R21, then here also by initially solving, you should be solving for R21, that is given by R1 minus R2. Okay, so keep it in mind. If it is exerted on force on the second charge due to the first charge, this is the procedure. If it is first charge due to the second charge, the procedure would be different. Okay, so those kind of problems are also you are going to see. Now substitute all the values. Okay, first Q1 charge, that is 8 into 10 power minus 4 into minus 10 power minus 4 divided by 4 pi. The value of pi is 3.14. Epsilon naught value in general is this, into magnitude of R square, that is 3 square, into the unit vector whatever we have solved. Okay, write it, solve it, simplify, see each steps very carefully what I have done. Okay, now what I have done is, there is 1 by 4 pi epsilon naught, right? This much. I've told you that it has one certain standard value, that is 9 into 10 power 9. So that I've substituted it, and rest all the terms I've kept it as it is. Okay, so this is divided by 9 here. So do the simplification part, that is 9 8s are 72. Then we have 10 to power 9 and 10 power minus 4, that is 10 power 5. And this you keep it as it is, 9 1s are, 9 8s are. Okay, so now what we are left with, 8 into 10 to the power 5 and 10 to the power minus 4 along with one minus sign, so 5 minus 4 is 1, that is 8 into 10 to the power 1 is 10, so 8 10s are 80, we have minus 80 along with this term. Okay, so 80 by 3 we would be getting 26.66, minus 26.66 into AX minus 2AY plus 2AZ, then multiply each of them with minus 26.66, and this is our final answer for the force. Okay, minus 26.66 AX plus 53.33 AY minus 53.33 AZ Newton. Okay, the SI unit of force is Newton, right? So this is the basic problem how it's going to be. Okay, so hope it is clear. Just go through this problem thoroughly once. So let us see one more problem now. Okay, so before discussing that problem, we have one important note here. That is, force acts along the line joining the two charges. Okay, so this is one point, and another point is force is attracted if the charges are of opposite side. Okay, what do you mean by force is attracted if the charges are of opposite sign? That is, the repelling of the charges takes place. If the charges are, one is positive and one is negative, according to the magnetic force, electromagnetic force, the force is attracted when we have unlike charges. Okay, if there are like charges, they would repel each other. If there are unlike charges, they would be attracting each other. If that's the case, then we have the force F21, that is charge due to Q1 due to Q2 is equal to the negation of F12, that is the charge on Q2 due to Q1. So this is one important note, that is F21 is equal to minus of F12, or F12 is equal to minus of F21. Okay, so before proceeding, I thought that this is necessary. Okay, yeah, so let us see that one more problem now. A charge QA, which is given by minus 20 into 10 power minus 6 Coulomb at mentioned as minus 6,4,7 meter, and QB is equal to 50 into 10 power minus 6 Coulomb at B of 5,8, minus 2 meter in free space. Again, they have mentioned it as free space, so the value of epsilon is equal to epsilon naught. Okay, they have told us to find the vector RAB and magnitude of vector RAB and force exerted on QA by QB. Okay, so based on the data, I have driven one graph here. Okay, the three-dimensional space where we are having 2 points in free space, charges in free space QA and QB with the values of -647 and 582 with respect to their coordinates. Okay, so draw two position vectors RA and RB. So combine these two QA QB charges, put a draw line, and this is force exerted on QA through QB. So from QB the vector is moving to this side, so the vector is here RBA. Okay, so according to the Coulomb's force of attraction, write the equation FBA is equal to QA QB, the two product of charges, divided by 1/4 pi epsilon naught into the magnitude of this whole square into the unit vector RBA. Okay, yeah. But here if you observe carefully, we have in terms of BA, but in the question they mentioned RAB. Okay, so while for further solving you should be keeping this note in mind. Okay, then only you could be solving for this problem. Okay, yeah. So now in order to find RBA, we know that what is RBA? RBA is equal to RA minus RB, right? So first find RA, that is with respect to QA, that is 6 minus 0, that is minus 6AX, or 0 is not required because any number subtracted by 0 it's itself only. So directly see the points and write the equation, that is minus 6AX plus 4AY plus 7AZ. Similarly B also 5AX plus 8AY minus 2AZ. Okay, so now you do RA minus RB. So you would be getting minus 6 minus 5 is minus 11AX, 4 minus 8 is minus 4AY, 7 minus of minus 2, that is 7 plus 2, that is 9AZ. Okay, so now since we want RAB, so we know that we have one rule, F21 is equal to minus F12. The force would be repelling each other. It's obvious that if the force repel each other, then the magnitude of the charges also would repel each other. Okay, would attract each other. So RAB is equal to minus of RBA. Okay, that is minus of this term. So minus of minus 11AX minus 4AY plus 9AZ, we would be getting the answer as 11AX plus 4AY minus 9AZ. Okay, now find the magnitude, the coefficient square into the whole square root, 11 square plus 4 square plus of minus 9 square, the whole root. If you solve it, you would be getting around square root of 218, that is 14.764 meters. Okay, now find the unit vector RBA. Okay, the one part is done, that is we have found RAB as well as magnitude of RAB. Okay, now the next part is to find the force exerted on QA by QB, that is FBA. Okay, in order to find FBA, what and all are the required terms here? We need to be finding RBA, magnitude of RBA the whole square. Okay, and the unit vector RBA. Okay, since the magnitude of RBA the whole square is equal to our magnitude of RAB the whole square, because either way we are just doing the square, right? So this minus sign won't come into the picture. So whatever the answer we got here, right, that only you should be considering. Okay, yeah, that is square root of 218. So this is the unit vector RBA. So now substitute one by one the values, all of them as mentioned here. Okay, do the substitution. 1/4 pi epsilon naught is written as 9 into 10 power 9. QA QB values you substitute, divided by R square vector RBA the whole square. We have square root of 218 we had, and it's a square, with the square and square root would be getting cancelled, we would be left with 218, and the unit vector RBA is given as 11AX minus 4AY plus 9AZ divided by root 218. Okay, so multiply 20 into 50 into 9, that is minus 9000 into minus 6 is minus 12, minus 12 plus 9 is minus 3 divided by 218, and this term here. So simplify this part here. Okay, so put in the calculator and simplify, you would be getting this term here, and further simplification our final answer would be, if we have 10 to the power minus 3 and it is mentioned as milli here. Okay, so 2.796 into 11 minus plus, so 30.756 AX plus 11.184 minus again plus 11.184 AY minus plus minus 25.164 AZ millinewton. Okay, so this is the force exerted on QA by QB, that is FBA. So in this way we should be solving the problem. So hope it is clear. So that's all for this video, guys. We have discussed two of the very important problems related to Coulomb's force of attraction, along with the definition part of the Coulomb's law statement and how the equation is formed. Okay, so hope you understood something from this video. Please like this video, share this channel to a huge number, guys. And already the further modules are uploaded for 4th sem module 2, 3, 4, 5. Please check it out, and please put your valuable suggestions in the comment if you like these kind of videos, don't like, and what kind of improvement you require. Okay, so that's all for this video, guys. Please do support us. Thank you. We'll see you in the next video.